Greetings, guys. Here is the topic, simplifying rational expressions. It's a very fancy way to say make sure you reduce your fractions. That's what it means. There are two steps involved. The first step is factor everything. But when you factor everything, you should always look for GCFs and the cube formula before you begin, because these are the two things that get overlooked the most and then cause havoc down the road. So GCF, remember, greatest common factor. Cube formula, that means if you have something cubed plus another thing cubed, it will break down, and we have a formula, and it does this thing. In case you did not write this down before, and that's called the sum of cubes. And if we have something cubed take away another thing that's cubed, it will break down like this. It's just a formula. And we actually just went over that in the previous video. So there we go. Look for that stuff first. You're going to factor everything. And when you factor stuff, then you are going to cancel what you can. Numbers reduce numbers. So if I have 2/6 in my answer, I would call that 1/3. That's what this is all about. Numbers reduce numbers. Variables cancel variables. Well, that's the quotient rule. We just talked about it. If I have something like this, I would say, hey, this guy is bigger, so I would subtract their powers. So that's what variables cancel variables is all about. Binomials cancel binomials, trinomials cancel trinomials. That is where we're going to add in some stuff. Now, let's go through some examples together, and then you guys are going to try it. So I have this ominous looking thing right here. And what I'm trying to get at is you can reduce this and make this more compact. That's your job. That's what's called simplifying a rational expression. Well, numbers cancel numbers. So, this does not count as a number to me. Those guys are binomials. So, I'm looking, when I say number cancels number, 2 goes into 6 3 times with 1 left over on the top. So, I am simply going to knock stuff out and see what's left when I'm done. Then I said letters cancel letters. So right here, I have x squared in the top. I have x to the first in the bottom. The top part is more powerful by how much? By 1. And you don't have to write the 1 there if you don't want to, but I don't want to lose you. Then I have a y to the 5th. That's a letter. That's a y to the 7th. I have 2 letters there. Who's more powerful? Bottom guy is 2 more powerful. And as you can see, I'm just working my way down this way. I did numbers first, letters second, so now I'm on binomials. The thing is, binomials will knock each other out if the exact same thing lives in the top and the bottom. But I tried to make this one a little sneaky. Do these two guys right here match exactly? No, they don't. So if they don't match exactly, you just keep track of them. So this would be the simplified version of this big ugly thing that we started with. So all I'm trying to show you guys is this is a fancy way to say reduce your fractions. Now, this is still an ugly looking dude. It is. But it's not as ugly as the original, and that's the point. We're trying to get things to go away that are in our way. So I have another one right here. The big difference between the first example right here and this one is there was no factoring that I had to do at all to get that to work. So right here, now I'm going to say, you know what? I could factor this piece right here. I could. I look at that and I go, you know what? X times x, that'll give me the x squared back. It ends with a -3, so it means opposite signs. And if I want it to match up, I would get a 3 and a 1. and I could factor that part up. Now, the nice thing about simplifying rational expressions is sometimes the problem itself will kind of help you look in the right direction. I see that in the bottom it started with an x plus 3, so you know what? I bet it's going to be an x plus 3 here, not an x minus 3. So I'm just trying to factor everything I can. But you know what? That's all I can factor in this problem. There's nothing else in it. So let's start knocking stuff out. Now I'm going to use a different color. So let's do blue, I guess. And I'm going to say letters. Who's more powerful? I think that the bottom guy is more powerful by 1. So I'm going to put that in the bottom. Then I say, well, I don't have anything else left except for this binomial and this binomial. They match exactly. So what lives in the top then? The top part is x minus 1. Now, fight the urge to knock these two guys out. See, here's the rule. If you follow this, I'm going to scroll back up for just a quick second. If you cancel things in the correct order, if you do things in the correct order, numbers only reduce other numbers. Variables will knock out other variables. Binomials only pick on binomials. And we're not looking at this yet, but trinomials only knock out matching trinomials. So when you go through it, always have a strategy. I'm going to look for numbers first. There were no numbers in this example. Then I looked for letters. Oh yeah, there were letters in this example. And then, there were matching binomials. But when I get to the end, just remember, a binomial will never pick on a single letter. So you could write the answer like that. That's totally cool. It's right. Or you could write the answer like that. Either way is fine. Let's continue. Remember, if you need to pause me, pause me. Okay, I see my first hint right here. My first hint was, if you're going to factor everything, look for GCFs. Sometimes a GCF is what you need. So in this one, I could take out a 2. So if I'm looking at this, I could take a 2 out, and then I'd need an x minus 3 to get this back. So get used to this. When you factor stuff up, remember, you're not going to cancel until everything is factored. That's when you try to cancel stuff. So write it in the correct order. If I have a 2 and I have an x to the 4th and I have a binomial, I'm going to write it in this order. There's the number first, the letter second, and then the binomial. It's called being polite. That's it. Then, in the bottom, I don't see any GCF. Well, what about this big chunky trinomial? Let's try and factor this guy. Now, I do see it's 15. And I know that 1 times 15 is one way to do that. But look at the top. The top part says x minus 3. So when I break this down, I'm going to try and work with the question. And I go, dang, that is how that thing breaks up. So if you want, you could rewrite all this stuff in the right order, in the correct order, and then start knocking stuff out. I'm going to go back to my red pen. I have the number 2. There is no other number in this problem. There is no other number, so 2 is going to stay in the top. But if I look at these two guys, they're letters now. I'm working my way down the list. Letter cancels letter, so who's going to keep it? The top or the bottom is more powerful. The top is. By how much? By 2. Then I'm going to go, hey, I'm going to knock you out. Mama said knock you out. What's left over? I have an x minus 5 in the bottom. And don't do anything else. If you go from top to, if you go numbers, letters, binomials, if you work your way down the list, these guys don't get to knock each other out. In our first lesson for this unit, we had monomial information and no binomial information. That's a monomial. That's a binomial. That's it. Monomials don't pick on binomials. So what you're going to practice in this is factoring and canceling. So let's look at this next one. I see juicy GCF-ness, but I wanted to make one like this so you don't blow it. Just because you see third power in a problem does not mean you're looking at the cube formula. Remember, the first thing you should take a look at when you're factoring is, can I take out GCFs? So in the top, 2 goes into both of these, and greatest common factor is based on the dude, right? So I'm going to say 2x squared. Build it back. If I started with 2x squared and I went like this and I brought it back, it would be x minus, what should go there then? It should be 5. That's the top. The top has been factored. I'm going to erase that arrow. Now on the bottom, hey, do you guys see another GCF? They all have what in common? They all have x in common. So I'm going to take that out, and then I end up looking at this thing. And this thing right here, hey, 20. It could be a lot of stuff. 1 times 20, 2 times 10, but I'm going to guess it's 4 and 5. Why? Because I see something in the top that might match up. So when it comes to simplifying a rational expression, let the problem help you see what should be there. I took out the x, so there he is. I'm going to break this guy down, and I'm going to say, you know what? X times x, the last sign is minus, so they have to be opposites. But I am going to probably assume that this is the correct way to go. And if you double check my work, you'll see, hey, that's how it worked. So once again, what's the pattern always? Numbers cancel numbers. There's a 2 here. There's no number here. There's nothing here. There's a 1. We just don't write it in because it looks weird. But I'm going to end up in my final answer, I'm going to have a 2 in the top. Let's just see what happens now. And I'm going to do letters next. Who's more powerful, top or bottom? This is called the quotient rule. We did this in the first video. I am more powerful by 1, so I'm going to keep it. Then let's knock out some binomials that match, and I'll end up with an x plus 4 in the bottom. And I'm going to stop working because a monomial will never knock out a binomial. That's the final answer. If you want to put this in parentheses, it won't change a thing. Some people like to leave it in parentheses to remember that they're not supposed to mess with binomials and monomials. So when you guys get to the practice problems, what you are going to see is practice doing this. I have 10 questions. Hang on, I'm just going to show you. So simplifying rationals. Problems, there's 7 problems there. So you could pause it and take a picture of it. And then you're going, wait a minute, I see multiplies and divides. I see this. What the heck? Well, let me show you. It's not something that's crazy. We know how to do this. So there's the first 7, here's the last 3, 8, 9, and 10. And I put a little mark here because I want to remind you, the cube formula is going to happen to you. And you want to know when it's about to happen to you. So let's talk about multiplying and dividing now. Let's get those ones done. And remember, there's always an answer key with everything I give you, so you can check your answers. Whoops, I can't, there, I can fit it all on one screen. There's all the answers. But let's talk about multiplying and dividing, because we haven't done that yet. So when we multiply and divide, it's the same rule they taught you in the 4th grade. Look at this, 2/10 times 14/16. In the 4th grade, they showed you can reduce. So like 2 can go into 10. You can go, that's 1 and that's a 5, right? Hey, this could reduce. I could totally reduce this because 2 goes into the top 7 times. 2 goes into the bottom 8 times. And then what did they tell you when you multiply fractions? It's top times top, bottom times bottom, and there's my answer, 7/40. But you know what? I could have canceled this a totally different way and it would have still worked out. I could have, and I'm just going to erase my red marks here, because I could have done it this way. I could have said 2 goes into 16 8 times, right? And I'd still have a 1 and an 8. I could have said 2 goes into that 7 times, 2 goes into that 5 times. Here's the rule with multiplying and dividing. When you multiply or divide, you can top to bottom cancel. You can also cross cancel. The only time you actually multiply is when you're going across. Top number times top number, there it is. Bottom number times bottom number, there it is. That's a simplified answer. And if they gave me something with letters in it and numbers in it, I can still use the same rules I did before. What goes into both 6 and 8? Well, 2 does. It goes in 3 times, it goes in 4 times. My final answer is going to have a 4 in the top, it's going to have a 3 in the bottom. Hey, what about these guys? One of them's in the top left, one's in the bottom right. Okay, well, if one's in the top, one's in the bottom, you can still reduce. The quotient rule still works. Who's more powerful? The bottom guy. By how much? By 2. So he's going to keep it, and that would be a simplified answer. That's it. So multiplying and dividing and simplifying are all kind of the same trick. It just looks scarier when there's multiply or divide in it because there's more stuff. But once again, all you're going to do is look for, do I have GCFs? Do I have cube formula? Can I break something down? And once you break it all down, then you just go through and go number cancels number, letter cancels letter, binomial cancels binomial, etc., etc. So look at this horrible mess. It's not as bad as it looks. First things first, I'm going to scan it for GCFs. And I'm going to say, hey, is this cube formula? No, it's part of a GCF. So it's not cube formula, so I'm going to say, okay, let's break that down. I'm going to use blue. I can take out a 6 because they both have 6 in common. I'm going to take out an x squared because they both have that in common. And I'm going to see what's left over. It's going to be a binomial that says x minus, what should go there? 5. That part's broken up. I'm not going to look at that again. I also see a GCF down here. I see a 2. I'm going to take that 2 out. And if I do, I'm going to end up with, it looks like this guy. And I'm going to say, you know what? That looks suspicious. Let's try to break that up. So I took out the 2. Now I'm going to try and break it down and say x times x, that's x squared. It ends with a plus, so it's got to be 2 minuses to get that, so I can get this back. And guess what? I'm using this in my vision saying, you know, it's probably 3 times 5. And if I wanted to check it, negative 3x minus 5x, there's my minus 8x. I got it. So I don't want to look at the wrong stuff. I already broke you down. So here's my top, here's my bottom. But guess what? I still have multiplied by this fraction. Well, let's break stuff down. Heck, you know what? This guy is the same as the other one. I could have broke them down. X minus 3x minus 5. I'm going to go back to that in a second. And then look at this dude. I could factor this guy. I bet you this guy, x times x, and it ends with a positive 20. So I'm going to guess to get minus 9 out of this, it's minus 4 minus 5. I bet you anything. So I now have everything broken down. I have done step 1, which is factor everything you can. Look for GCFs. Look for the goodness. Now we're going to start canceling stuff. Now, when I cancel stuff, the big stuff always sticks out. I see that I got an x minus 5, I got another x minus 5. I got an x minus 3, I got an x minus 3. What the heck, I got another x minus 5, x minus 5. I've got big stuff in the way. I can reduce all that junk. It's easy. You never miss the big stuff. It's the tiny stuff that you got to be careful about. So here's my word of advice. There's a number and a letter here. There's a number here. What I always do is I always work with numbers first. Then I go through and I do binomials. I do all that other stuff because it's the tiny stuff that you forget. See, 2 does go into 6. 3 times. I get a 3. There's an x squared in the top, but there's no single letters in the bottom. This is a binomial. Binomials don't pick on single letters. So I'm going to say you stay in the top. And I'm going to say, what about this? Well, leave him down there. He's down there. This is definitely simpler looking than the original problem. Totally simpler. Now, I did mention something. When I pulled the 2 out here, do you see how this trinomial matched up with that trinomial? I could have just knocked that sucker out right there. I could have. I didn't. I broke everything down first. But if you see a matching trinomial that matches another trinomial, you can take it out. Just a reminder, I'm going to scroll back up. The whole game of simplifying rational expressions is you factor everything, look for GCFs, look for cube formula, and then cancel what you can. Numbers knock out numbers, letters knock out letters, binomials knock out binomials if they match, and trinomials can cancel trinomials if they match. This last part, this trinomials can knock out other trinomials part, that's important when you see cubes. And let's take a look at something that has cube formula in it. And then remember, you have 10 practice problems. So here we go. Let's look at the last example here that has cubes in it. Whoop, wait, that's the one that has cubes in it. So where are the cubes? Well, this is a cube, but it's a monomial. This is a cube. It's part of a binomial. What? Yeah, that's what I'm talking about. And this is when you say to yourself from the cube video that we watched before this, what times itself 3 times is going to give you that? X. What times itself 3 times is going to give you that? Well, take a guess. It's 5. 5 times 5 times 5 is 125. So if I use the formula, I would say this thing plus this thing. And then this is just plugging it into the formula. That's all I'm doing. Nothing fancy. But the reason why you want to always see if you have cube formula in something, if you have cube formula, it sometimes leads you to realize that, hey, I see a GCF down here. I wonder what would happen if I took out the 2. And what I'm trying to get at is, check it out. Do you see it? Do you see it? Come on. That's a big old chunky trinomial that matches with another chunky trinomial. You can take them out. But let's finish factoring first. We haven't finished factoring. I see a GCF. That looks GCF-alicious. So I'm going to take that out. All right. I factored you. You're factored. I factored you. You're the formula. You, I couldn't do anything with, but it doesn't mean I'm done because I see a little singleton over here and a single letter here. See the single letters? All the single letters? Oh, oh, oh. Let's knock some stuff out. So I'm going to use blue for that. What the heck? So I see the big boy. You knock out you. You're gone. So let's see what we have left. Ooh, big stuff. Big stuff is easy to see. Those are gone. So the only thing left over is this guy in the bottom, and he's a first power. This guy's in the top. He's a third power. So the top keeps x squared. And then you go, cool, I'm done. And then you have to remember my hint. It's not the big stuff that you miss. It's the little tiny things that you miss. Oh, crap, there's a 2 in the bottom. That's what this thing becomes. That is what that thing becomes. That huge, ugly mess turned out to be that little answer. So what are we doing here? We're doing simplifying rational expressions. When you multiply or divide, you get the same type of vibe from these things. So, sorry, I had one more right here. This is the division problem. So I want to make sure that you guys know when you see divide, it's the same trick it was in the 4th grade. I am going to copy down the first question, the first part, and then on the second one, I'm going to flip it and turn it into a multiply. So when you guys do the problems in the whatchamacallit, in the practice, if you see a division question, you can copy it down and make it a multiply instead. And let's start picking at this thing. I see a GCF in one of these pieces, and that GCF is right in here. They both have 4 in common. Let's change colors here. So I'm going to go 4 comes out. Take out the GCF. And then I go, okay, that's as far as that's going to go. So how about we start messing around with these guys? See, I know that this is probably got something, x times x. The only way to write 7 is 1 and 7. So I'm going to guess, hey, you know what? If I put a minus here and a minus here, I'll get a match in the top and the bottom. See, let the problem help you kind of steer your thought process. Okay, you've been factored, but you have not, so let's break this guy up. And I say x times x, and I go, okay, well, I'm not going to get a 7 out of this, I don't think. But let's see, x, I think it's plus 8x minus 1 is how that one will factor. Hey, what happens when you have this situation? Let me change colors. I got this guy in the bottom. He can knock out this one. You don't get a 2-for-1 special. One binomial takes out one binomial. You don't get 2-for-1 special. No way. So this guy's going to make it through. So let's keep track of what's happening here. That x minus 1 is definitely still in the top. Well, wait a minute. Do these two guys match up? They're binomials. No, they don't match up. Oh my gosh, there's going to be this guy in the top also. And this guy in the bottom? Okay. See, I collected all the big stuff. The big things in the problem are not going to be missed. It's the tiny stuff. So remember, go back. You got a 2x here. You got a 4 here. 2 does go into 4. They're just numbers. 2 goes into 4 twice. So I can keep the 2 on the top. What about me? There's no other single letter. Put it in the bottom. That's your answer. How do you know it can't get smaller? Well, 2 is the only number in the problem. There's no other number in the bottom. So 2 is done. Check. There's a single x. There's no other single letter in the problem. X is there. These guys are all binomials, and none of them match exactly with each other, so I would say the answer is finished. So, once again, if you see a division problem, just flip the second fraction, make it a multiply, and what do? You factor. You factor first. Whatever you do, it's factor first. Cancel second. Those are the 2 steps involved, and don't forget about cube formulas because they do exist. My thing is running out here. So, once again, here's the practice problems. Simplifying rationals, there's 7 on the first page. I tried to space them out so they were easy to work. And then there's 3 more. And look in problem 9, you should see some cubes formula. And look in problem 10, you should also see cube formula. And if you do not see cube formula, you come back in the Zoom room and ask for help so I can help you. And here's the answer key. All right, good luck. I will see you guys on the other side.